Hey internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we want to find the electrical power generated from the wind turbine. The wind speed is 8 meters per second. The efficiency of the turbine is 31%. The diameter from the blade tip to blade tip is 82 meters in diameter. The air density is 1.25 kilograms per meter cubed. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. We've got wind going to the turbine, and it turns the turbine that generates power. Step 2, list all the given values, find the unknown. We're trying to find the electrical power, which is W dot, which is work flow rate. So wind speed is 8 meters per second, density is 1.25 kilograms per meter cubed. Efficiency of the turbine is 31%. Step 3, find the electrical power formula. So it is the efficiency multiplied by the maximum power. They give us the efficiency. So we need to find the unknown for the maximum power. So we need to find the formula for the maximum power. So that is equal to the mechanical power, which is equal to the mass flow rate multiplied by the specific mechanical energy. Both of these are unknown, so we need to first find them. Step 5, find the mass flow rate formula, which is m dot. So that's density multiplied by velocity multiplied by area. Area in this case is area of a circle. So we have all the values. So step 6, we just plug and play. So density of air multiplied by wind speed multiplied by area of the circle from blade tip to blade tip, which is 82 meters in diameter. So you'll get 52,810.17 kilograms per second for your mass flow rate. Step 7, find the specific mechanical energy. So it is kinetic energy, as we are only given velocity. So that is velocity squared divided by 2. Step 8, plug and play. So 8 meters per second squared divided by 2. Then convert your units with a conversion factor. You will get 0.0320 kilojoules per kilogram. Step 9, we want to find the maximum power. So now we can backtrack. So originally we're on step 4, so we're backtracking to step 4. So mass flow rate is found in step 6 right here, and specific mechanical energy is found in step 8 previously over here. Okay, so we multiply these together, and the units will cancel out the kilograms, so you're left with kilojoules per second. 1 kilojoule per second is equal to 1 kilowatt, so it's a 1-to-1 conversion. So you will get 1,689.93 kilowatts. And finally, to find the power for electricity or electrical power, we multiply the efficiency with the maximum power. So 31% multiplied by 1,689.93 kilowatts. It gives you 523.9 kilowatts for the electrical power. So that is the value that the wind turbine can generate. Note that the power generation of the wind turbine is proportional to the cube of the wind velocity. So the power generation will change strongly depending on the wind conditions. Disclaimers: the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things happen. You can do this by using snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. So click on the icon in your taskbar to open up the program. If it's not there, go to your Windows search, type in snipping tool, open the program. Once you have it open, click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button, wait for the countdown in snipping tool. Hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.